All right, let's go through these two, A and B. You shouldn't have done too much work for A because we read the directions. It says state whether it's a function. If it is a function, state the domain, range, and intervals on which it's increasing, decreasing, or constant. So you should have looked at that first one and just looked at the vertical line test and just said, hey, it hits at 2 points. So it's not a function, so you don't have to do anything else. The second one is a function because it passes the vertical line test. Because no matter where I draw a vertical line, it's only going to hit once. So if I draw it there, it hit once. If I draw it here, it hit once. But anywhere you draw it, it'll only hit once. So it is a function, so we do have to state the domain and range and the intervals in which all of those things are happening. Let's go right to the domain. Can someone give me the domain of this function? Nick, I saw your hand first.
Negative infinity to positive.
Perfect. All right, range. I need a range. David?
Bracket 1 to infinity.
Bracket 1 to infinity. So you're saying the lowest point is 1, and the highest point goes up forever? Yep, perfect. All right, increasing. Yeah, Luke.
3 to infinity.
3 to infinity. Parentheses or brackets?
Parentheses.
How do you know it's a parenthesis?
Because we don't know if it's still going to stay.
When do we use brackets for increasing, decreasing, and constant? Never. Okay, awesome. All right, so this is going to go 3 to infinity.
You almost have me confused.
You're like, wait, when do I use it? So if Pierre the ant was on here and he started at x equals 3, he'd be going uphill forever. Yep. All right, that's my increasing. Decreasing is going to be what? Someone new? Someone new?
We're all old boring people.
Yep. 1? Yep, negative infinity to 1. Parenthesis or bracket by 1? Parenthesis. All right. And finally, constant. Who can give me the constant? Erna.
1 to 3.
1 to 3 with brackets, right? No brackets. Parenthesis. Of course we use brackets. I like to lose points on the test. I'm just going to put brackets on everything. All right, always parentheses. So,
Did I say of course brackets?
Yes.
yeah.
Oh, I thought you said parentheses.
Oh, no, I said brackets. You're like, of course. I thought you were being snarky. I didn't.
I thought you said parentheses. Funny.
All right, just remember with increasing, decreasing, constant, the three main things: work left to right, use x values, and use only parentheses. Don't overthink it. Always parentheses with increasing, decreasing, and constant. The only time you have to worry about brackets are in domain and range. All right, yes?
Okay, so when this is like a math question.
Okay.
So when you're like graphing a line, like on like a line graph,
Mm-hmm.
when the circle is closed, it is inclusive.
Yep.
And when it's open, then you use a
Parenthesis.
parenthesis.
Yep.
Okay.
So a lot of times on line graphs, instead of open dots and closed dots, I use parentheses and brackets. Yep, but you are 100% correct. All right, what questions do we have from the homework? Fatima. 21. So 21 was probably one of the most difficult ones, just because we have both of them being squares. Whenever you have a y squared and an x squared in there, you have to recognize it is a circle. Anytime you have an x squared and a y squared in the same thing, it is a circle. And remember the circle formula. The circle formula is x minus h squared plus y minus k squared equals r squared. Now, I'm not going to give you super complicated ones. I'm going to give you ones that look like this. Because if I readjust that y squared equals 1 minus x squared to look more like the one up there, I would just have x squared plus y squared equals, well, that'd be like 1 squared. You can kind of look at it that way. Note there is no h and there is no k, so both of those must be 0. So this is, in fact, a circle with the center at the origin. So the center of this circle is at the origin because my h is 0, my k is 0. So if I was to graph this, I would just do that, and all I'd be thinking is, okay, the center of the circle is right there. The radius goes from the center to the outside of the circle, and my radius is 1. because the square root of 1 is 1. So my radius is 1. So that means my circle goes out to 1, up to 1, over to negative 1, down to negative 1. So my points would be here, 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 here. So my circle would look something like this. Well, that means the furthest left it could go is negative 1. The furthest right it could go is a positive 1. So that goes from negative 1 to 1. The range goes from from negative 1 to 1 as well. However, it is not a function. It does not pass the vertical line test. Is that good enough, you think?
Yeah.
Makes sense? All right, awesome. Other questions? Maybe I'll write that down here real quick, because our range would be, and we'd use brackets, negative 1 to 1, and our domain would also be negative 1 to 1 with brackets because they are closed lines. Yeah.
So, if you could you not draw like a vertical line at the very edge of the circle and just catch 1 point?
Yes, you could.
You could.
But the vertical line test has to work across the entire graph.
Oh.
You
Like
can't
any
just pick and
place.
go, oh, it's function right here.
Like any place.
Any place. So even if you have something that looks like, a nice little it just does that. That is not a function because that one little thing doesn't pass the vertical line test. If any little part of the function doesn't pass, the whole thing is not a function. You get rejected. That's the sound that makes. Other questions? Yeah, Fatima.
47,
I guess I don't have that one up here, so let me just look at 47. 47, say that again, I'm sorry.
for the second one.
Yep.
For the increasing, decreasing constant.
Mm-hmm.
For decreasing, shouldn't it be negative infinity to 4? And then for increasing, shouldn't it be 4 to infinity?
Are we talking about decreasing?
Hmm?
We're talking about the decreasing one on the second one?
Yeah.
So let me just take a picture real quick. So you want the decreasing to go from 4 to negative infinity?
Yeah.
Question. So the 3 things we need to know about increasing, decreasing. We work left to right, we use x values, and we use parentheses. Is 4 to negative infinity using x values?
No.
No. You would have to say 0 to infinity. That is correct. It's hard. It's hard because you wanted to say, oh, it decreases from 0 to, from 4 to infinity because that's the top point and that's the bottom. We always work left to right using x values. Yeah, one.
The second 49.
Mm-hmm.
Why would the answer key said domain was negative infinity to 2 with a parenthesis?
It should have. That's a mistake.
And then the other one is also range with a parenthesis, not a bracket.
Yep, those should both be brackets. Yep, you are 100% correct. So on 49, it should be negative infinity to 2, bracket, and the range should be negative infinity to 3, bracket. That is a good catch.
Is that extra credit?
That is extra credit.
Oh, wait, is it only 1 or is it 2?
It's 1.
Wait,
Okay.
So once again, the answer key is wrong on number 49. It should be the domain is negative infinity to 2, bracket, and the range should be negative infinity to 3, bracket. Both those should be brackets. Do you want me to take a picture of it?
wait, number 49?
Yeah, I don't have a picture of it up.
Oh, okay.
Number 49.
Oh, 49.
49. All right, other questions? Yeah.
Got it, okay, thank you.
Is 15 is x equals radical y.
Mm-hmm.
Could you square both sides?
You could, but you're losing something. So if you square both sides, so if we go down that route, if we square both sides and we say x squared equals y, we're going to come up with the fact that my domain can be any value, right? Negative infinity to positive infinity. However, that's not necessarily true. And why it's not true is how we started out. We started out with just the square root of y. All right? And the square root of y What can't we have under our square root? A negative value. So our y value has to be bigger than or equal to 0, which means our range needs to be 0 to infinity. But with our domain, the smallest range value I can have is 0. So the smallest, if I plug 0 in there, is square root of 0. I can't have this actually being negative. I think the easiest way to do these is do them backwards. Don't square both sides. Just ask yourself what values of y work, and then what values of x can I get out with those values. All right, so our domain would have to be 0 to infinity as well, because the smallest range can be is 0, so the biggest domain can be is 0 as well. All right, it's kind of, and here's where it gets really confusing. It's kind of, so if you were to graph this, it'd be half a graph, because if I wanted the full graph, we would need x equals plus or minus square root of y. Then I could rewrite it as x squared equals y, and everything would be satisfied. Because when I take the square root of both sides, I need plus and minus. The fact that this isn't plus or minus tells me, and honestly, the easiest way to do that one is just work backwards. Find your y values first, and then find your x values. All right, same thing on this one. Find what y values work, and then figure out what x values can result from that. All right, so it's almost like you're finding your domain, your range first, and then you're finding your domain. Makes your life a little easier. Does that make more sense, less sense? Somewhere in the middle? A little bit more? Okay. Other quick questions? All right, then today we're going to move into some stuff. Piecewise functions. Piecewise functions are just a way to plot a bunch of functions in different spots of our xy plane. So my example is, so we can create functions that behave differently based upon what x value we're talking about. So my example here is when x is less than 2, ooh, that should say it, not if. It gives you x squared. So when x is less than 2, so if we look here, x is 2 here, let's find x equals 2 on this graph. And a good thing to do with piecewise functions is as soon as you know some kind of value like x equals 2, what I always do is I draw a dashed line, and you'll see how I do that on my next ones, because this one's already done for us. So it's saying when x is less than 2, draw x squared. So I draw x squared up until when I get to this line. Note that it says strictly less than, so that's why I do an open dot. Just like Nick was saying, I'm excluding that one point. Yep, I'm excluding that one point. Well, our next thing says when x is exactly 2, it gives us 6. So when x is 2, I better have a solid dot at 6. Because at 2, I should have a solid dot at 6. Then it says when x is more than 2 and less than or equal to 6. Once again, we're saying when x is 2 or less than x equals 6. So what I would do is at x equals 6, I'd put a little dashed line and say something either ends or begins there. Well, it says draw the line 10 minus x. It is strictly more than 2. So that means I have an open dot because it's not equal to. I draw 10 minus x until I get to this line. Now I decide if it's an open or a closed dot here. It is a closed dot because it does say it's less than or equal to 6. Yes?
Those open dots, those dots would still be a function.
It would not be a function.
So the only reason it is because they're open dots.
Yep. Yep. No, that's a great point. And it's a good thing to check when you're drawing your own. If you have two closed dots on top of each other, it's no longer a function, which means you broke something because all of these are going to result in a function. Yep. You're not going to see it in these sentences. All right? We're going to write it more mathematically. So in fact, we're going to write this one more mathematically and how you'd see it written down below. So how this is written is we're going to start out with f of x. We're going to say I have some function. And we have three possibilities. Either it's going to equal x squared. So I'm going to write x squared. Or it's going to equal 6. or it's going to equal 10 minus x. Now the next part is just telling me where those occur. All right, where does x squared occur? Well, x squared occurs when x is less than 2. So we're just going to put x squared for x is less than 2. Fx is just going to equal 6 for when x actually equals 2. And x is going to equal, or f of x is going to equal 10 minus x for when x is somewhere between 2 and 6, but it's strictly greater than 2, and it's less than or equal to 6. It's somewhere between 2 and 6. Yes?
Is that top sign backwards?
Yes.
Okay.
Juan, is that what you're going to say too?
Yeah.
Yeah, it should be x is less than 2. Did I say greater than or did I say less than?
I think you said less than.
Okay, I said it. At least I said it. I did 50%.
I want to make sure.
But what I want to point out here, look at these numbers here. This x and 2, 2 and 6. That means your key thing should happen at x equals 2 and x equals 6. That's why I do have dashed lines at x equals 2 and x equals 6. It's nice having those dashed lines, and you'll see what I mean when we're doing bigger ones and harder ones. All right, that one's done for us, so hopefully it's right. Minus that greater than, less than sign.
Should we put a closing brace on it or no?
I'm sorry. Where?
Like here, should we?
No, you don't close it.
Okay.
That is how it's set up.
Okay.
It's kind of like if I do f of x equals x squared, at no point do I say and it's over.
Oh, okay.
Yep.
Okay. Oh, right.
It's just doing branches like, hey, you can go up here. If this happens, you can go down. It's one of those adventure books. You get to pick your path. All right. They're fun. I don't know. It says graph the relation and state the domain and range. So we're just supposed to graph what's happening here. So we have either f of x can equal 1 or f of x equals negative 1. Remember, if f of x equals 1, that is the same thing as saying y equals 1. And y equals 1 is a horizontal line at 1. F of x equals negative 1 is a horizontal line at negative 1. So I should have two horizontal lines on here. Whenever I start a piecewise function, I look first here. I look at what it says here. Note it says x less than 0 and x is greater than or equal to 0. So it means something happens at x equals 0. That is our changeover part. Yes, it's half. So what I do is, because I have this nice little colored pencil, I'm going to put a dashed line at here. Now, if it's ever on the x-axis and I can't see my pencil, just do that little scribble thing, where you scribble down so you can actually see that something important is going to happen there. But something important is going to happen right at x equals 0. On the left-hand side, we have x is less than 0. On the right-hand side is where my x is greater than 0.
Or equal to.
I'm not going to put the equal to because equal to is actually right. You can put that down. All I'm saying to myself is whenever x is less than 0, it's going to happen here. The stuff that x is greater than 0 is going to happen over here. We'll worry about the equal to sign with the closed dot, open dot. But feel free to put whatever you want on here. I don't grade what you put on here except for the actual graph that you're doing. All right, let's look at the x is less than 0. That's here. That says my f of x has to equal 1. Well, that means I'm going to have a horizontal line that goes all the way to 1. But the question is, we have two possibilities. Either that horizontal line is going to collide at x equals 0. It's either going to collide as a closed dot or an open dot. So we know it's going to be a straight line. It's going to stop here. Now my only question is it a closed dot or is it an open dot? Those are our two choices. Look at it, it's flashing. Is it flashing for you? Yeah. All right. Which is it, closed or open?
Open.
It's going to be open because it's just strictly less than. Since this one's greater than or equal to, we know this one's going to have our closed dot. And this is where f of x equals negative 1. F of x equals negative 1 is a horizontal line that goes straight through negative 1. But I can't draw, you can't do this. I can't just go straight across because I'm just looking at where x is greater than 0. So we're going to start at that dashed line with a closed dot because it is greater than or equal to. Draw our line, and we still have a function.
Yes, because it is a closed and an open dot.
It is a closed and an open dot. And Juan pointed that out earlier. If you do not have a function, you did something wrong. If you get to the test and you're drawing something and you have graphs on top of graphs, you did something wrong. Fix it. All right. The domain and range it's a little weirder. Yeah.
So we always take that first number and we go up or down the y-axis.
Yeah, until where it's going to meet. Yeah. So if this was x, fx equals positive 4, we would have went up to 4 and then went that direction. And we'll have other graphs with it, right? We might have x squared, we might have negative x, and we'll go through ones that are more complicated. I like this one. Not hard to graph. Yeah, sorry.
I have a question about the domain.
Yeah, what's the domain?
Is it going to be a union or something like
It is actually not going to be a union.
that? Would it just be negative and positive?
It would be negative infinity
Because one is inclusive.
to positive because 1 is inclusive. There is no gap. Any x value has a y value associated with it. Negative 4 goes to 1. Negative 1 goes to 1. X equals 0 actually comes down to negative 1. So it goes negative infinity to infinity because there is no gap. If for some reason this would have been an open dot.
Can you have two opens, but
Yes, you
not
can.
two closed?
Correct. Yeah, because 2 opens is still a function. It's just I have to go from negative infinity to 0 and then 0 to infinity for it. Yeah, but we do have open and a closed. Range. Yeah.
This is -1 union 1.
Negative 1, union 1. Yeah, that's one way to put it. I'm going to put it a little simpler, but you are not wrong. I'm just going to say it's negative 1 and 1. Because when we use these braces, I am strictly saying it's negative 1 and 1. If you use parentheses here, pay attention. If you use parentheses here, you have the wrong answer. You are saying y can be anything between negative 1 and 1, which it cannot. It has to either be 1, negative 1, or 1. So braces basically mean either. Either this or that. You can actually have like 4 or 5 things in there. So braces for when it's only 2 things, or 3 things, or 4 things. All right, does that make sense? Why I use braces instead of parentheses? Cool. All right. Logic behind this is about as hard as piecewise functions get. All right, the logic point of this, that we have dashed lines that are dividing different functions happening. And a lot of it's just going to be plotting points to get the right stuff. So that's exactly what we're going to do here. We have f of x being 2 things. We need either to be x squared minus 4 or x minus 2, and they tell me where those 2 things occur. Let's just focus on that x squared minus 4. We'll take care of that first, and then we'll do the next part. X squared minus 4 is 4 negative 2 to 2. So those are my x values. So what I'm looking at here, what I'm focusing on is, see this negative 2 and this 2? I'm going to put dashed lines at x equals negative 2. And 2. And the function I'm looking at is somewhere between these 2 things. So what I just drew here is our negative 2, x, 2. And you could put your equal to sign, Nick. I don't care. I don't care what you put there. I just want you to recognize what area that is. That tells me a graph's going to start here, and it's going to end here. I just have to worry about what points work and whether it's going to be a closed or open dot. And if I look up here, they're both actually going to be closed dots because they both have equal to signs. So I'm going to have a closed dot somewhere on this negative 2, and I'm going to have a closed dot somewhere on 2. Now to figure out what to do with that, we're just going to plot some points. So I'm going to say I make a little table where I have x values and x squared minus 4. To know which ones to pick, we know it has to start at negative 2 and it has to go all the way to 2. So it's always a good idea to pick points that are right on those dashed lines I just did. So I do want to do a negative 2, and I do want to have a 2 in there. But I also want to see what happens between those. So let's go ahead and just do negative 1, 0, and 1. Sometimes you just need 1 point in between. This one we could have just used 0 and you would have known what was happening, but we're just going to plot all of those. So when I plug negative 2 into x squared minus 4, I get negative 2 squared, which is 4, right? Because a negative squared is positive. I have 4 minus 4, which gives me 0. Negative 1 squared is a positive 1, minus 4 is a negative 3. 0 squared is 0. 0 minus 4 is negative 4. 1 squared is 1, that will give me a negative 3. 2 squared is 4, that will give me a 0. Let's plot those points. Once again, do we see our first point is negative 2, 0. It's on the dashed line. If it's on a dashed line, you have to, every single time, ask yourself, is it open or is it closed? I already told us all these dashed lines are going to be closed because it is equal to. It is 2, negative 2 is less than or equal to x less than or equal to 2, so both of those will be closed dots. So at negative 2, 0, it will be a closed dot. Then let's do negative 1, negative 3, 0, negative 4, and we also have a closed dot on the other one. And that is just a parabola, which makes sense because it's x squared. X squareds are parabolas. And we'll learn, I think tomorrow, that negative 4 is just going to drop us down 4. We're done with that first one. That's all that first one gives me. My next one says x minus 2 for x is greater than 2. Notice there is no equal to sign, so this is going to be an open dot. So at x equals 2, we're going to have an open dot for this function. Well, this isn't a hard one to do. You could probably do it in your head. But I'm just going to pick the points. We know 2 is important because it's a dashed line. Let's just do 2, 3, 4. 2 minus 2 is 0. 3 minus 2 is 1. 4 minus 2 is 2. Let's plot those points. So I'm supposed to plot 2, 0. And it's supposed to be an open dot. So there's supposed to be an open dot right here, right?
How do we know what numbers to plug in for x?
How did I pick those? What's our x value for that dashed line where it starts off at?
2.
So I'm going to pick 2. And I'm going to pick 3. I'm going to pick 4. I'm just going to pick a couple after to see what's happening. If you need to pick more, you might have to pick more. All right. You kind of have to have a general idea of what the shape should be. So I knew that x squared should be kind of a parabola, so I kind of knew let's graph all the ones that are in the middle kind of thing. Sometimes you have to graph a whole bunch to see what's happening. I know this is a straight line because it's x minus 2. I actually know what this looks like because slope-intercept form, slope of 1 intercepts at negative 2. So my bit of advice is pick the points that are on the dashed lines and just a couple after. Does that help a little bit? Does it make sense to put an open dot over a closed dot?
Yes.
No.
Oh, wait, like on top of it?
Yeah. No. So we're just going to, it just happens that an open dot is over that closed dot, so it's going to remain a closed dot. All right. And then we're going to plot 3, 1, 4, 2, and this is just going to look like this. Now don't write this, but I just want to hypothetically talk about this. If that didn't collide right at 0, let's say it collided here, then it would be an open dot if I would have a line that did that. All right, but because of the fact that that open dot occurred right where a closed dot happened, you're just going to leave it like that.
Because the closed dot
Is already there.
is it?
Yep. I wouldn't take any points off if you put an open dot around a closed dot, but it just doesn't make any sense because it's closed. Yeah.
How do you know, like, when you're plotting the graph, the points on the graph, do we use the open or closed dot?
You're going to know it from this. So see how this was just strictly greater than? The graph that meets this one will be your open dot.
So every single point from that,
Yep.
like, equations.
Yep, exactly. So see how this is negative 2 is less than or equal to x? This equation is going to have a closed dot at negative 2. It's also going to have a closed dot at 2.
And what if it had both? Like, negative 2 is greater than or equal to x, and then just greater than,
Just less than 2? Then that would be, this would be the open dot portion of it.
So you'd have, like, the same graph would be half open, half closed?
Well, So this one would be closed. I think what you're saying is, instead of this, we had -2 is less than or equal to x is less than 2.
Yeah.
It would be closed at -2, but it'd be open at the 2 part of it. So yeah, one would be closed, the other side would be open.
And the other 3
And the other 3.
points in the parabola.
Oh, those are always closed, because that actually exists on the graph. We're just using it to help graph it.
Oh, okay.
Yep. The only time we're worried about open and closed is at the dashed lines. That's where we do the dashed lines.
Okay.
That's the only time you're worried about open and closed. All right, the next one's going to go pretty quick. What time are we over? Are we running behind? A little bit. That's okay. All right, we're supposed to just identify open intervals where the function's increasing, decreasing. Oh, I kind of rushed through this. Domain. I'm going to go through the domain. We just don't have a ton of time. Our domain should be from -2 bracket to infinity, because our leftmost point is -2, and then it goes right forever. Our range is going to be from -4 to infinity, because our lowest point is -4, our highest point is infinity, and everything's hooked up together. Yes. Okay. Oh, wait a minute. There we go. Graph and identify any open intervals. So this is just 4 minus x squared. If you're ever not sure which points to pick, like Nick said, just pick -2, -1, 0, 1, and 2, and see if it works. If you need to pick other points, then you do that. So I'm just going to randomly pick -2, -1, 0, 1, and 2. Hope it graphs a parabola, because I know this is going to be a parabola. When we plug 2 in, we're going to have 4 minus 2 squared. 2 squared, or -2 squared, is going to be 4. 4 minus 4 is 0. -1 squared is a positive 1. 4 minus 1 is 3. 0 squared is 0. 4 minus 0 is 4. And then it just goes 3, 0. So our graph is going to be -2, 0, -1, 3, 0, 4, 1, 3, and 2, 0. Your friend, Pierre, I wasn't going to do Pierre, but I was going to say your friend in doing piecewise functions is plotting points. But then we use our friend Pierre to say where it's increasing and decreasing. I'm going to go through this as well, just to save us a little bit of time. Increasing, you should come up with x values, left to right, using only parentheses, would be -infinity. All the way, so Pierre's climbing all the way up until he gets to x equals 0. And then he's going to slide down that slope from 0 to infinity. Once again, left to right, x values only, parentheses also only. All right, the last one. The last one, we're supposed to graph. Oh, sorry.
Would we do domain range for that too?
Did I ask for it? No, I didn't. So no, you don't have to worry about it. If you did, I wouldn't take points off, but
Good deal.
good. That was a good deal. All right. Once again, we have one that's split off into 3 different equations. Now, kind of in my mind, I'm focusing on what these equations mean. G of x equals 0 is a horizontal line at 0. G of x equals square root of x. That's going to be that one just kind of shoots off. G of x equals 2 is a horizontal line at 2. So we should have all 3 of those somewhere on this graph. Let's focus on just that 0. Let's focus on just that 0 for x is less than or equal to 0. Notice the equal to sign, so I'm going to have a closed dot on this one. On the dashed line, we'll have a closed dot. It also says x needs to be less than or equal to 0, so let's go ahead and do a dashed line at x equals 0. Because something happens at x equals 0. The left-hand side of this will be x is less than 0. So that left-hand side is the side I'm plotting this g of x equals 0. Well, since g of x equals 0 and g of x equals 0 is just a straight line, maybe I should do it in purple. Let's do it in red. No, let's not do red. I did red. What will show up? Green will show up. Can we see that? That full line is g of x equals 0, but I do not graph the entire line.
Just the left half.
Just the left half. Left half. Left half. Get it back to that green. Now I just have to have myself closed or open dot. Closed or open dot. Closed or open dot. Who can tell me which one? Yeah. Closed.
Oh, I thought you meant the next one.
Oh, no. The next one is going to have nothing but open dots, right? But this is going to be another one that has kind of the overlaps. So this is one of the times maybe I don't know what the square root of x looks like. Well, we're trying to graph the square root of x. Let me highlight it. Let's use, I guess, blue. All right, this one goes from 0 to 4. X is somewhere between 0 and 4. So at x equals 4, I'm going to do another dashed line. Because that little section right there is my 0 less than x is less than 4 section. So in that little section, I'm graphing square root of x. Pretend like we don't know what square root of x looks like. I know 2 points I need to check. I need to check the point that's on this dashed line and one on this dashed line. So I definitely need to check the points where x equals 0 and x equals 4. I'm also going to pick a point somewhere in there that works, and I'm going to pick 1 because I know what square root function is. So the square root of 0 is 0. Square root of 1 is 1. Square root of 4 is 2. Well, at 0, 0, I'm supposed to have an open dot for this function.
But you can keep it closed.
But I can keep it closed because it's already closed. All right, then let's plot 1, 1. And 4, 2. At 4, 2, would that be an open or closed dot? 1? Did you have your hand? Oh, sorry. Okay.
I assume it'd be open.
You assume it would be open?
Yeah.
You are correct. It would be open because it's just x is less than 4. It's going to end up getting closed in a second, but for right now, it's open because it was open for this function. Our last one we have to draw is this 2 for x is greater than or equal to 4. So that is g of x equals 2. And what that means to me is I'm looking at a line that goes through 2, kind of like this, but can't go across that entire space. It just has to be in that section where x is greater than 4. So that line is just going to be right here. Now, because it is greater than or equal to, we do have to close the dot where it started from. So the purple actually closes that dot. The blue one I have up there is open, but that purple one closes that dot. A good idea to do on your test is, especially if you think something might be a little funky or something seems off, is what I would do is I would write the function names above them. So that's g of x equals 0. This is g of x equals square root of x.
We don't have to, though.
You do not have to. G of x equals 2. And the reason why you might write it is maybe you made a mistake graphing it. And at least then I know what you meant to put in there. It also helps because I can look at this visually and say, all right, when x is less than 0, I'm using g of x equals 0. Yep, that's what this says. Between 0 and 4, I'm supposed to use square root of x. 0 and 4, square root of x. Yeah, that's right. X is greater than 4, use g of x equals 2. Yep, that is right as well. All right, so it's a little helpful to check your answers. But obviously, you don't have to do it. And if time is a concern, then don't. All right, questions for me on any of that?
We still have to do the...
Did I skip something? Oh, we need domain and range?
No.
Oh, increasing, decreasing. Okay, I'm going to cover that because we're running out of time. All right, let's just do constant first. Will be constant from negative infinity all the way to 0. And we're going to union that with 4 to infinity. And then I just have to worry about increasing. It will increase from 0 until 4. Any questions on those increasing, decreasing constant values I came up with? You have to come up with your own scales for all of these. My advice to you, and this works for almost all of them, is just go 2 spaces, 1, 2 spaces, 2. It gives you a lot better zooming area. That will work for most of them.
Zoomage.
All right, everyone, have a wonderful day.